Quick disclaimer, information in this podcast is for general informational purposes only and is not intended to be treated as medical advice. Always consult with your healthcare team before making changes to your diet, lifestyle, supplementation, or medication.
We've been told for years that a calorie is a calorie. But what if some sugars affect the body differently than others? What if a calorie isn't a calorie? Listen up as we discuss one interesting sugar that blows this myth in two.
Welcome to Type 2 Diabetes Talk, the place where we chat about what really works to treat type 2 diabetes and prediabetes naturally with nutrition and lifestyle. If you're looking to optimize blood sugar and A1C, lose weight, reduce medications, and improve your overall health, this is the place to be. Now, here's your host, Type 2 Diabetes Nutrition Specialist, Dr. Jeddah.
Hello, wonderful people. Thanks for joining me for episode 124. We've been told for years that a calorie is a calorie, that every calorie is the same. But what if some sugars affect the body differently than others? What I'm about to share today isn't really anything new. It's something that's been known for some time and talked about by researchers for quite a long time. But a new paper published recently is once again putting fructose under the spotlight, suggesting it may act less like a simple sugar and more like a metabolic trigger involved in obesity, fatty liver, insulin resistance, and chronic disease. Today we're unpacking what fructose actually is, how it behaves differently inside the body, why modern diets may be creating problems our biology wasn't designed for, and most importantly, what this means in practical everyday life. Let's start with a basic question. What exactly is fructose? Fructose is a type of sugar that occurs naturally in foods. You'll find it in fruits, honey, and even some vegetables. It's also one of the two sugars that make up ordinary table sugar, known as sucrose. When you consume table sugar, you're getting roughly equal amounts of glucose and fructose. Fructose is also now highly produced and found in high fructose corn syrup, a sweetener that's commonly used in soft drinks, confectionery, baked goods, sauces, and many ultra-processed foods. Now, whenever fructose comes up in the media, there's often a tendency for people to immediately think fruit is the problem. But that's not really what researchers are concerned about. The fructose found in a whole apple, peach, or a handful of berries arrives packaged with fibre, water, vitamins, minerals, and other beneficial compounds. It takes time to chew, digest, and absorb. Most people are not consuming excessive amounts of fructose from whole fruit. Yes, in diabetes, fruit still needs to be eaten in moderation, but the point is, the bigger concern is what has happened to our food environment over the past several decades. Today, fructose is often consumed in huge amounts through sugar-sweetened drinks, soft drinks, energy drinks, sweetened coffees, fruit juices, desserts, confectionery, syrups, and countless ultra-processed foods. These foods deliver sugar quickly, requiring very little chewing, and are often easy to overconsume. This distinction is important because when scientists talk about fructose contributing to metabolic disease, they're generally not talking about someone eating an apple after lunch. They're talking about dietary patterns characterised by high intakes of added sugars and highly processed foods, which is common in our modern environment. In fact, if we look at where most added sugars come from in our modern diet, sugary drinks remain one of the largest contributors. These beverages can deliver large amounts of fructose in a matter of minutes, often without creating the same feeling of fullness that comes from eating whole foods. So, while fructose itself isn't new, and it's certainly not a newly discovered sugar, researchers have become increasingly interested in whether the body responds differently to fructose compared to other sugars, particularly when it's consumed in large amounts through modern processed foods. And the reality is fructose is doing much more than simply adding extra calories to our diet. For many years, the dominant view was that all calories were essentially the same. Whether those calories came from fat, protein, glucose, or fructose, or any type of processed food, the thinking was that weight gain and metabolic disease simply resulted from consuming more energy than the body needed. People were simply told, eat less, move more. We've all heard that, but that's not the case. While calories certainly matter to some degree, different nutrients can influence the body in different ways. There is no doubt about that. And this is where fructose has attracted so much attention. Unlike glucose, which can be used by almost every cell in the body, fructose is handled quite differently. Most fructose is processed by the liver, and it enters metabolic pathways that are less tightly regulated than those used for glucose. Fructose acts as much more than just a source of energy. Researchers describe it as a metabolic signal capable of activating biological pathways that favour fat production, energy storage, and increased food-seeking behaviour. One of the mechanisms they discuss involves ATP, which stands for adenosine triphosphate. You can think of ATP as the energy currency of your cells. Every process in your body relies on ATP to function. When fructose is metabolized, ATP levels can temporarily fall. And research believes this may trigger a series of responses that encourage the body to conserve energy and seek additional food. So in simple terms, the body may interpret this as a signal that resources are becoming scarce, even when food is actually abundant. Fructose metabolism can also increase uric acid production and stimulate pathways involved in fat creation within the liver, a process known as de novo lipogenesis. And over time, these changes may contribute to fatty liver, elevated triglycerides, insulin resistance, and other features of metabolic syndrome. Now, before anyone panics, it's important to remember that these are biological mechanisms. A mechanism by itself doesn't prove that fructose is solely responsible for obesity or type 2 diabetes. Human health is far more complex than that. But certainly, when we look at the historical timeline and the way that disease has developed and gotten worse over the years, we can certainly see that the consumption of increased added sugar, which is a combination of glucose and fructose, has been a key driver in many of these diseases. And what makes these findings interesting is that they may help explain why certain foods, namely processed foods, do drive hunger, weight gain, and metabolic dysfunction more readily than others. We know in today's modern environment, many people consume highly palatable, calorie-dense foods around the clock. In the environment we live in today, sugar-sweetened beverages, desserts, takeaway foods, snack foods, and ultra-processed products are never more than a few minutes away. And that leads to overconsumption of fructose, with the potential to activate these biological pathways that can contribute to metabolic diseases such as obesity, fatty liver disease, prediabetes, and type 2 diabetes.
Are you ready to take charge of your diabetes health? Dr. Jetta's T2 diet program has been clinically proven in a randomized controlled trial to dramatically reduce A1C, weight, and medications in just 16 weeks. The T2 diet program will guide you step by step to discover an eating plan that feels natural and sustainable for you, and most importantly, works to get results. Learn more and join the program today at type2diabetestalk.com/programs.
One of the reasons fructose has become such a hot topic in metabolic health research is its connection to fatty liver disease and insulin resistance. If you listen to the podcast for a while, you'll know that I often describe fatty liver as one of the major warning signs that metabolism is starting to go off track. Fatty liver is incredibly common, particularly among people with prediabetes and type 2 diabetes, those who might be overweight or obese and living with insulin resistance. You see, the liver plays a central role in processing nutrients, regulating blood sugar and managing energy storage. When excess fat begins accumulating in the liver, it can interfere with many of these important functions. Researchers have long observed that diets high in added sugars, particularly from sugar-sweetened drinks, are associated with increased liver fat and higher triglyceride levels. And fructose has received particular attention because it is primarily processed by the liver, where some of it can be converted into fat. The authors of this new review suggest that fructose may contribute to several processes involved in fatty liver development. These include increased fat production within the liver, reduced cellular energy availability, and metabolic changes that can promote insulin resistance over time. Insulin resistance occurs when the body cells become less responsive to insulin, making it harder for glucose to move from the bloodstream into the cells where it can be used for energy. As insulin resistance worsens, blood sugar levels begin to rise, and the pancreas is forced to produce increasing amounts of insulin to compensate. This is one of the reasons fatty liver and insulin resistance are often seen together. They tend to feed into one another, creating a cycle that becomes increasingly difficult to break. Now, it's important to keep this in perspective. This doesn't mean that eating a piece of fruit causes fatty liver, as we mentioned at the beginning of the podcast. Nor does it mean that fructose alone explains why someone develops insulin resistance, prediabetes, or type 2 diabetes. What matters most is the overall dietary pattern, someone's overall eating plan. For example, drinking several soft drinks every day delivers a large amount of rapidly absorbed sugar directly to the liver and a lot of fructose. The same can be true for sweetened coffees, those energy drinks, fruit juices packed with fructose, sports drinks, desserts, confectioneries packed with fructose, and many ultra-processed foods, all containing huge amounts of added sugars and fructose. And as we pointed out, by contrast, whole fruit contains fibre, water, and nutrients that slow consumption and digestion. Most people become full long before reaching the level of fructose typically seen in studies examining excessive sugar intake. So in other words, the concern is not fructose in isolation. The concern is chronic overexposure to added sugars within a modern food environment that makes overconsumption of added sugar and fructose remarkably easy. For people with pre- and T2 diabetes, fatty liver, or elevated triglycerides, this distinction is particularly important. One of the most effective ways to improve your health is often not through obsessing over every gram of fructose, but by reducing the major sources of added sugar and ultra-processed foods that place the greatest burden on the liver and metabolism. And that's where the practical take-home message begins to emerge. Certainly, reducing fruit can be beneficial for diabetes, and we spoke about fruits to avoid in episode 84, but fruit overall isn't generally people's challenge. An apple isn't simply a delivery system for fructose. As we said, it contains lots of other beneficial compounds that influence the way it affects your body. But when you consider the difference between, say, eating 2 apples and drinking a large soft drink, yes, both contain sugar, but they are very different eating experiences. Most people would feel quite satisfied after eating 2 apples, but the soft drink, on the other hand, will be consumed in a matter of minutes and it will have little impact on hunger at all. So the old saying that says a calorie is just a calorie, well, it's just not true. Calories are not just calories because the food matrix and what that food contains influences your body differently. It's important to pay close attention to the foods and drinks that deliver large amounts of sugar with very little nutritional value in return. Those sugary drinks, the processed foods and added sugars that have become a routine part of modern eating patterns. Those are the kinds of food you want to get out of your eating plan because they're really not serving you any benefit at all. Before we move on, let's hear a testimonial from one of our members.
Karen said, "My results: 36-pound weight loss and A1C lowered from 10.6 to 6.2. The thing I love the most is the library. If I have a question, it's easy to look up the answer. I love getting new menus each week too."
As interesting as the fructose research is, there's a danger in focusing too heavily on any single nutrient. Nutrition science has a long history of searching for that one thing responsible for chronic disease. At various times, fat was blamed, then saturated fat, then cholesterol, then carbohydrates, now sugar. Well, sugar does have an area of blame in this, that's for sure. But the thing is, human metabolism is pretty complex than any one nutrient acting alone. So the reality is that many different conditions can develop through the interaction of many contributing factors. Certainly, diet plays a major role, a major role. But so does physical activity levels, sleep quality, stress, genetics, muscle mass, age, medications, overall lifestyle patterns, our environment, many different things. This doesn't mean fructose is irrelevant. That's not the point I'm trying to make. The biological mechanisms discussed in this latest review are certainly very important and supported by a growing body of research. But fructose is unlikely to be the entire story. There's just so many more complexities, I think, in modern life that have come to the fore. But certainly our food environment and added sugar, the added fructose has certainly made a big impact. We've seen study after study after study showing those influences of that sugar, that fructose, those ultra-processed foods on people's health. But again, two people could consume the same amount of fructose and have very different outcomes depending on their overall metabolic health. Someone who's physically active, maintains a healthy weight, sleeps well, and eats a largely whole food diet may respond very differently compared to someone with significant insulin resistance, who's not active, who might already have fatty liver, who sleeps poorly, and eats a highly processed diet. So this is one reason why I encourage people to focus less on individual nutrients and more on their overall eating pattern and the quality of their nutrition plan. A useful way to think about it is that your body doesn't experience nutrients in isolation. Every meal is a package of information. The foods you eat influence hunger, your feeling of fullness, your blood sugar, your insulin levels, your inflammatory molecules, liver fat accumulation, and energy regulation. And this all happens simultaneously. Take two meals that contain the same number of calories. One might consist of a sugary soft drink, a packet of cookies and a candy bar. The other might be salmon, vegetables, avocado, and a handful of nuts. On paper, the calories may be similar, but the way your metabolism responds is going to be very different. One meal is likely to leave you hungry, again, pretty quickly. The other is likely to provide all that nutrition, protein, fibre, healthy fats, the vitamins, the minerals, and a much greater sense of fullness. And this is why the old statement that a calorie is a calorie doesn't tell the story at all. Calories matter to some degree, but the source of those calories can influence how much we eat, how hungry we feel, and how our metabolism responds. So the real lesson from this fructose discussion isn't that we should obsess over every gram of sugar. It's that the modern food environment contains many foods and drinks that are remarkably effective at driving overconsumption and metabolic dysfunction. Certainly, we all know sugar is a big craving source. It drives us to eat it, right? And while those foods can be sometimes foods, they just don't have a place in our regular everyday eating plan if we want to be in the best health possible. So what should we take away from all of this? Well, firstly, while this new review has generated headlines, the idea that fructose may contribute to metabolic disease is not really new. Researchers such as Richard Johnson, Robert Lustig, and many others have been exploring these mechanisms for many years. We know they're true and they are real. But what this paper does is bring together a large body of evidence and reinforce the idea that fructose acts as more than simply a source of calories. It is having a really big impact on biological pathways in the body that can contribute to the development of health conditions. Second, the biggest concern is not whole fruit. The evidence continues to support the inclusion of whole fruits as part of a healthy eating plan. And of course, in diabetes, we know there are some fruits we should avoid, but overall, fruit is not the major issue here. It's those added sugars. So that's the third point. The real concern is the amount of added sugar people consume through those sugary drinks, desserts, confectionery, ultra-processed foods. Huge amounts of sugar delivered to the body very, very quickly. This is what's causing a lot of metabolic problems in everybody across the world. So from a practical perspective, the message remains remarkably similar to what we've been discussing for years. Reduce or eliminate sugary drinks where possible. Tick, please. Be mindful of added sugars hidden in processed foods. And it literally is hidden everywhere. So you must read food labels. Read the ingredients on food labels. Prioritize whole, minimally processed foods. Build meals around quality protein, non-starchy vegetables, healthy fats, and other nutrient-dense foods that support your body to function at its best and help to stabilize blood sugar levels. And most importantly, don't get distracted by sensational headlines. Nutritional science rarely comes down to one nutrient being solely responsible for disease. The bigger picture still matters. Thanks for joining me today. If you found this discussion interesting and you enjoy the podcast, please head to the website type2diabetestalk.com/review to share your thoughts and a review to help promote it to others. I'd really appreciate that. Until next time, keep learning, keep questioning, and keep focusing on what actually works. Dr. Jetta, over and out.
Thanks for tuning in to Type 2 Diabetes Talk. Please subscribe to the show on your favorite podcast platform. And for episode replays, episode notes, and more, visit type2diabetestalk.com. New episodes are available Tuesdays, 10 a.m. U.S. Eastern Time, or your time zone equivalent. Thanks again. We're truly grateful to be a part of your life and help make a real difference.